Think of a big, powerful compressor. It's a beast of a machine, full of parts spinning and sliding at incredible speeds. Now imagine all that metal rubbing together without any help. It would get hot, grind to a halt, and destroy itself in moments. That's where the Lube Oil System comes in. It is the absolute best friend a compressor could ever have. This system is like the machine's circulatory system, pumping life-giving oil to every critical part. It's not just about making things slippery, it's a complex and vital support system that does several important jobs all at once, ensuring the whole operation runs smoothly and doesn't just turn into a very expensive paperweight. The most obvious job, of course, is lubrication. The oil creates a super thin, microscopic film between all the moving metal surfaces. Think of the bearings, pistons, and rotors. This oily film prevents them from ever actually touching each other directly. It's like a tiny liquid cushion that dramatically reduces friction. Less friction means less wear and tear on the components, which is brilliant because it means the compressor can run for thousands of hours without needing major repairs. It also means less energy is wasted fighting against its own internal resistance, making the whole machine more efficient. It's the difference between dragging a heavy box across concrete and pushing it on wheels. But the oil is also a world-class cooling agent. As a compressor squashes gas, it generates a tremendous amount of heat. This heat has to go somewhere, or the internal parts would overheat, expand, and seize up. The lube oil is constantly flowing through these hot spots, absorbing that thermal energy like a sponge. It then carries this heat away to a cooler, where it can be safely released. This continuous cycle of heat removal is crucial for keeping the compressor within its safe operating temperature range. Without this cooling effect, the machine would cook itself from the inside out in no time at all. And there's more. The oil is also a cleaner. As it circulates, it picks up tiny bits of dirt, metal shavings from wear, and other contaminants that could cause damage. It's like a janitor constantly sweeping the inside of the machine. These particles are then carried to filters, which trap them and remove them from circulation, keeping the oil in the system clean. In some very clever designs, the oil also works as a hydraulic fluid, using its pressure to move other parts, like valves or actuators. And in certain types of compressors, it even acts as a sealant, filling the tiny gaps between moving parts to stop the compressed gas from leaking out. It's a true multitasking marvel. Now we get to a really clever bit of engineering. Many high-performance lube oil systems are kept under a vacuum. That might sound a bit strange. Why would you want to create a vacuum in the oil tank? The answer is simple: to keep air out. Air is the enemy of lubricating oil. When air, which contains about 21% oxygen, gets mixed into the oil, it causes all sorts of problems. The vacuum creates a space where there is very little air, which stops it from being whipped into the oil as it circulates. This simple trick is one of the most important things you can do to protect the health of the oil and the compressor itself. The biggest problem with air is that it causes oxidation. Oxygen reacts with the hot oil, breaking it down and changing its chemical properties. This process is a bit like how an apple turns brown when you leave it out. For oil, oxidation makes it thick and sluggish, and it can lead to the formation of nasty stuff like sludge and acidic compounds. Sludge is a thick, tar-like substance that can clog up narrow oil passages and filters, starving critical components of lubrication. The acids, meanwhile, can corrode the metal parts of the compressor from the inside. By keeping the system under a vacuum, you remove most of the oxygen, which dramatically slows down this destructive oxidation process. A vacuum also provides excellent protection for the compressor's seals. These seals are designed to keep the oil in and the processed gas out, or vice versa. When the lube oil system is under a vacuum, it creates a pressure difference that helps the seals do their job more effectively. It ensures that any potential leakage is directed inward, preventing valuable processed gas from contaminating the oil and stopping oil from leaking out into the environment. This is especially important in compressors that handle expensive or hazardous gases. The vacuum acts as an invisible barrier, helping to keep everything exactly where it's supposed to be. Finally, the vacuum helps to pull out any trapped gases that might already be in the oil. Gases can get dissolved in the oil during the compression process. These dissolved gases can be a real menace, as they can come out of the solution later and form bubbles, a bit like opening a fizzy drink bottle. These bubbles can lead to a condition called cavitation, where tiny bubbles collapse with great force, damaging parts like bearings and pump impellers. By maintaining a vacuum, you encourage these trapped gases to escape from the oil in the reservoir, keeping the oil pure and free of bubbles. This degassing process keeps the oil clean and extends its useful life significantly. So, what happens when this carefully balanced system starts to fail? Let's say the vacuum is lost and air starts getting in. The first thing you'd likely see is foaming. As the oil pump churns the oil, it whips the air into a frothy mess, like making a cappuccino. Foamy oil is terrible at lubricating because it's full of air bubbles, not solid liquid. This means the protective oil film between moving parts can break down, leading to direct metal-on-metal contact. The result is rapid wear, soaring temperatures, and potentially catastrophic damage to bearings and rotors. It's a fast track to a very expensive failure. If the problem isn't fixed, the long-term effects of oxidation will begin to take their toll. That nasty sludge we talked about will start building up throughout the system. It will clog the oil filters, reducing oil flow to a trickle. When the filters are blocked, the compressor's vital organs are starved of lubrication and cooling. Bearings can overheat and seize, gears can be stripped of their teeth, and the entire machine can grind to a screeching halt. This isn't just a minor inconvenience. A major failure can shut down an entire industrial plant, costing a fortune in lost production and repairs. The formation of acids from oil oxidation creates another set of problems. These corrosive compounds will begin to eat away at the internal metal surfaces of the compressor. This can weaken parts over time and create even more tiny metal particles that contaminate the system, making everything worse. It's a vicious cycle of destruction. Furthermore, if the oil's hydraulic properties are compromised, systems that rely on oil pressure to function, like control valves, might stop working correctly. This can lead to erratic compressor performance or a complete shutdown. The machine loses its ability to regulate itself, making it unreliable and unsafe. Ultimately, a failure in the lube oil system is a failure of the entire compressor. It is the machine's life support, and without it, the outcome is predictable and grim. The smallest issue, like a leaky seal or a faulty vacuum pump, can cascade into a complete mechanical meltdown. This is why the lube oil system is monitored so closely. It provides the earliest warnings that something is wrong. Ignoring these warnings is like ignoring the oil light in your car. You might get away with it for a little while, but sooner or later you're going to end up stranded on the side of the road with a very big bill. Given how critical the lube oil system is, it's no surprise that keeping a close eye on it is a top priority for any operator. You wouldn't drive your car for years without ever checking the oil, and the same logic applies here, but on a much bigger and more expensive scale. Regular, daily checks are the simplest and most effective way to ensure the compressor remains healthy, reliable, and safe. These checks are like a daily health screening for the machine, allowing you to spot small problems before they spiral into massive, plant-stopping disasters. It's all about being proactive rather than reactive. The three most important things to check every day are the oil's temperature, pressure, and of course, the vacuum level in the reservoir. A sudden increase in oil temperature can be a sign of trouble, perhaps indicating that a bearing is starting to fail or that the oil cooler is clogged. Likewise, a drop in oil pressure is a major red flag. It could mean there's a leak somewhere, the oil pump is failing, or the filters are blocked. Both of these conditions require immediate investigation because they signal that the oil is not reaching the places it needs to be, or it's not providing enough cooling. Checking the vacuum level is just as important. If the vacuum reading is not as low as it should be, it means air is getting into the system somewhere. This could be due to a worn-out seal or a leak in the piping. As we've seen, letting air in is the first step toward oil foaming, oxidation, and sludge formation. By catching a loss of vacuum early, you can find and fix the leak before the oil's quality is ruined. It's a simple check that can save you from having to perform a costly oil change and system flush down the line, not to mention preventing long-term damage. In the end, the lube oil system is the beating heart of the compressor. It performs a whole host of thankless but absolutely essential jobs, from lubricating and cooling to cleaning and sealing. Paying close attention to its vital signs, pressure, temperature, and vacuum, is fundamental to good maintenance. These simple daily checks provide the peace of mind that this incredible piece of machinery is protected and ready to do its job safely and efficiently. A happy lube oil system means a happy compressor, and a happy compressor is one that runs reliably for a very long time.